Hello students, welcome to Physical and Chemical Equilibrium question part 3. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the image. So in this question session, I will be showing you questions, so as well as I will be dictating the questions along with the options. Then you will be given some time to solve them. After that, I will give you the correct answer with the explanation. Question says that an aqueous solution contains 0.10 molar H2S solution and 0.20 molar HCl. If the equilibrium constant for the formation of HS minus from H2S is 1.0 into 10 to the power minus 7, and that of S2 minus from HS minus is 1.2 into 10 to the power minus 13, then the concentration of S2 minus ions in aqueous solution is, your options are A, 5 into 10 to the power minus 8 molar, B, 3 into 10 to the power minus 20 molar, C, 6 into 10 to the power minus 21 molar, D, 5 into 10 to the power minus 19 molar. So you have some time to solve this question. Your time starts now. So your time is up. For those who have solved it, the correct answer is B, 3 into 10 to the power minus 20. Okay, so this is your correct answer. Now it was given that the concentration of H2S is 0.10 molar and that of HCl is 0.20 molar. Now since your HCl is a strong electrolyte, so the concentration of H plus and HCl will be same, that is 0.20 molar. Now again, what was given? It was given that the formation of HS minus from H2S has an equilibrium constant of 1 into 10 to the power minus 7, and the formation of S2 minus from H minus has an equilibrium constant of K2 is equals to 1.2 into 10 to the power minus 13. Therefore, if we add both of these equations, we will get the equation for the ionization of H2S into 2H plus and S2 minus. Simultaneously, we can get the equilibrium constant for this equation by multiplying these two. So when we add equations, then the equilibrium constant gets multiplied. We have studied this. Now multiplying both of this, 1.0 into 10 to the power minus 7 and 1.2 into 10 to the power minus 13. We will get 1.2 into 10 to the power minus 20 as your equilibrium constant for this equation. Now, further, we know that if we want to calculate S2 minus, then how can we calculate? It will be K into H2S by H plus square. We have seen the equation earlier. Now we know K here. We know that H2S concentration is 0.1 and H plus concentration will be mainly decided by the H plus HCl. Okay, because H2S contribution to H plus concentration is very less and can be neglected. Therefore, we are taking the contribution from HCl only for H plus. So this puts here 0.2 whole square. Now, if we solve it further, so 1.2 into 10 to the power minus 20, 1.10 into 10 to the power minus 1, and 4 into 10 to the power minus 2 from here. Further, if we solve it, then we get the answer as 3 into 10 to the power minus 20 molar. Next question. Nitrogen gas plus hydrogen gas, 3 moles of hydrogen gas gives us 2 moles of ammonia gas, whose equilibrium constant is K1. Nitrogen gas reacts with oxygen gas to give 2 moles of NO gas, which is having an equilibrium constant of K2. And hydrogen gas is reacting with half moles of O2 to give 1 mole of water, whose equilibrium constant is K3. Now we have to find the equation for the equilibrium constant for the reaction, which is involving the reaction of 2 moles of ammonia with 5 by 2 moles of O2, giving us nitrous oxide, 2 moles of nitrous oxide plus 3 moles of water. Now we have to write K4, which is for this reaction in terms of K1, K2 and K3. Your options are K1, K2 by K3, B, K1, K3 K3 square by K2, C is K1, K2, K3 multiplied, then D is K2, K3 cube by K1. So you have some time to solve this question. Your time starts now. So your time is up. For those who have solved it, the correct answer is D, which is K2 multiplied by K3 cube divided by K1. In the required equation, the solution says that NH3 is on LHS. So invert the equation 1. So we have first inverted the equation 1 to get our equation 4. Now since we have inverted equation 1, therefore the new equilibrium constant, which is written as K5, will be inverse of the initial one, which is K1. So K5 equal to 1 by K. Next, now there are 3 moles of H2O. So we multiply the equation 3 by 5 by 3. Okay. So when we are multiplying the whole equation by 3, therefore your new equilibrium constant K6 will be cube of the previous one. Clear? The same thing is written. So when a reaction is multiplied by n, then K becomes K raised to the power n. So it is multiplied by 3. So K3 is now turned into K3 cube. K2 will be taken as it is. Now if we add equation 4, 5 and 2. Okay. So this is equation 5. We will add 4, 5 and 2. Then we will get our required equation. Now since we are adding this, so we will multiply K5, which was inverse of K1, K6, which is cube of the K3, and K2 as it is. So this will give us K4. Now putting the value of K5 and K6, so this was K5 and this is K6, will give us this equation, which is option D. Next question. Next question. The equilibrium constant Kc for the reaction nitrogen reacting with 1 mole of oxygen to give 2 NO gases at temperature T is 4 into 10 to the power minus 4. The value of Kc for the reaction, for the same reaction at the same temperature is, so we have taken a new reaction which is giving us half mole of N2 and half mole of O2 from 1 mole of NO. Your options are A 0.02, B 2.5 into 10 to the power minus 2, C 4 into 10 to the power minus 4, and D 50. So you have some time to solve this question. Your time starts now. Okay, your time is up. For those who have solved it, the correct answer is D 15. Now this was our initial equation. So first what we will do, we will write Kc for this equation in terms of the concentration of reactants and products. So Kc will be concentration of product raised to the power, which is equals to the stoichiometric coefficient, so therefore 2, and N2 and O2 are having coefficient 1, so they are written as it is equals to 4 into 10 to the power minus 4. This is given. Now what do we need to do? We first need to reverse this equation. So we have reversed it, and then on reversing this equation we get this. So therefore our new equilibrium constant for this equation becomes 1 by Kc of the initial one. So your new equilibrium constant, which is K dash C, it becomes 1 by Kc. So that is N2 reacting N2O2 by NO whole square. See, these are now the products, and this is the reactant, and this is your stoichiometric coefficient. So upon doing this, we get 1 by 4 into 10 to the power minus 4, which will give us 10 to the power 4 by 4. Now, we don't need here 2. So we have divided the whole equation by 2. So same thing will be done accordingly to the equilibrium constant. Now your new K double dash C will be 1 root under of your initial, that is K dash C. So what I am trying to say is your K double dash C will be root under K dash of C. Why? Because we have multiplied the whole equation by 1 by 2. So putting this value here, so C root under K dash C is root under 10 to the power 4 by 4. So that will give you 100 by 2 and 50. At last is your correct equilibrium constant for this equation. For the following equilibrium, N2O4 decomposes to N2NO2 in gaseous phase. NO2 is 50% of the total volume when equilibrium is set up. Hence, percent of dissociation of N2O4 is options are A 50%, B 25%, C 66.66%, and D 33.33%. So you have some time to solve this question. Your time starts now. Your time is up. For those who have solved it, the correct answer is D 33.33%. So this was our initial equation. Now it is being said in the question that your equilibrium, when your equilibrium is set up, your NO2 is total is 50% of the total volume. Suppose the initial mole of N2O4 is 1 and that of NO2 is 0. So as the equilibrium proceeds, so we are taking that X moles of N2O4 has been broken and simultaneously 2X moles have been formed because 1 mole is forming 2 moles of NO2. Then what is the total number of moles? So it will be 1 minus X plus 2X. That will give you 1 plus X. Further, it was written that percentage of NO2 by volume. Okay, so that will be volume of 2NO2, which is NO2, which is 2X, and total volume will be taken as 1X. So why are we taking moles instead of volume? Because volume is what written as V equal to nRT by P. Now R and T and P, all these three are constant. Therefore, they will get cut off, and they will be remained with number of moles. So this thing is given as 50. If I solve for X, then we get it as 0.33. Further, the percentage will be 33.33% of N2O4. This is your percentage dissociation. Because we have assumed here that X moles are broken, and this is nothing but a percentage or your percentage ionization. So this is your fractional ionization. You multiply it by 100, you get the percentage. Next question. At certain temperature, a total pressure of 10 to the power 5 Pascal, iodine vapors contain 40% by volume atoms. Kp for the equilibrium constant, equilibrium I2 gas gives us 2I gaseous will be. Options are A 0.67, B 1.5, C 2.67 into 10 to the power 4, D 9 to 10 to the power 4. So you have some time to solve this question. Your time starts now. Okay, your time is up. For those who have solved it, the correct answer is C 2.67 into 10 to the power 4. This was our equation. Now partial pressure of iodine atom will be 40 by 100 into 10 to the power 5. Okay, so this is our partial pressure. Because pressure is pressure volume is given that 40% of the iodine vapor contains 40% of the volume, so we can write it in this way. Okay, now that corresponds to 0.4 into 10 to the power 5 Pascal. So this is our partial pressure of iodine. Now partial pressure of I2. So this was of iodine atom. Now this is of iodine molecule. So that will be remaining percentage, that is 60 by 100 in 10 to the power 5, 5, that is 0.6 into 10 to the power 5 Pascal. Now Kp is given as 10 to the power 5 Pascal. So we put the value here for this equation, which will give you 0.40 into 10 to the power 5 whole square by 0.60 into 10 to the power 5. On calculating this, we will get 2.67 into 10 to the power 4 as your correct answer. Next question. For the reaction N2O4 decomposing to give 2 moles of NO2, the degree of dissociation at equilibrium is 0.2 at 1 atm pressure. The equilibrium constant Kp will be, options are A 1 by 2, B 1 by 4, C 1 by 6 and D 1 by 8. So your time to solve this question starts now. Your time is up. For those who have solved it, the correct answer is C 1 by 6. So this was our equation. Initially, we are considering that we have 1 mole and 0 moles of this are present. Now, we are considering alpha as the what? Alpha as your degree of dissociation. Okay. Now, since alpha is degree of dissociation, then alpha amount will be broken from 1 and 2 alpha amount will be formed because 2 is written as the coefficient here. Now, moles at N2O4 at equilibrium will be addition of these two, which is N2O4 and NO2, which is 1 minus alpha plus 2 alpha. That will give you. So, now moles of N2O4 will be how much? Moles of N2O4 will be 1 minus alpha, which is this one. Okay. And we will put the value of alpha 0.2 here. Similarly, moles of NO2 will be 2 alpha, which is 2 into 0.2. That is 0.4 mole. So what is the total number of moles at equilibrium? It is 0.8 plus 0.4, that is 1.2. Now, what will be the pressure of N2O4? So it will be mole fraction of N2O4 multiplied by the total pressure, which is 1 atm. That will give us 2 by 3 atm. Again, moles of NO2 will be mole fraction of NO2 multiplied by total pressure, that is 1 by 3. Hence, Kp can be calculated using this values of pressure. So we will have NO2 whole square, which is 1 by 3 square, divided by 2 by 3. It will give us 1 by 6 as your Kp. So, next question. Question says that at 30 degrees Celsius, Kp for the dissociation reaction, that is SO2Cl2 gaseous reacting to give SO2 and Cl2 gaseous, is 2.9 into 10 to the power minus 2 atm. If the total pressure is 1 atm, the percentage degree of dissociation of SO2Cl2 is, assuming that 1 minus alpha square is equals to 1. That is the approximation. Now options are 87%, B 13%, C 17% and D 29%. So your time to solve this question starts now. So your time is up. For those who have solved it, the correct answer is C 17%. So this was our equation. So initially we are saying that we have 1 mole of this and 0 moles of this and 0 moles of this. Now after equilibrium, alpha is the part that has been dissociated from the SO2Cl2 and that same amount will be formed on the product side. So 1 minus alpha, alpha and alpha. Because this equation is balanced, we don't need to balance it. So what will be the total number of moles? So we'll add these three, 1 minus alpha plus alpha plus alpha, that will give you 1 plus alpha. And further, the pressure of SO2Cl2 can be written as how much? So that will be 1 minus alpha by 1 plus alpha. Okay. So why are we writing this directly as the pressure of SO2Cl2? Because pressure of SO2Cl2 will be nothing but the mole fraction multiplied by the total pressure. And since total pressure is 1, so your pressure of SO2Cl2 is simply your mole fraction. Similarly, your pressure of SO2 is alpha by 1 plus alpha and your pressure of Cl2, which is chlorine, is alpha by 1 plus alpha. So this is the pressure of partial pressure of all of these three. Now further, Kp can be written as alpha by 1 plus alpha, we are written in whole square divided by 1 minus alpha by 1 plus alpha. So we have put all the values. That will give you alpha square by 1 minus alpha square. So if you just see this, then alpha square is this thing, and it was earlier said that 1 minus alpha square can be approximated to 1. So our equation of this one is becoming this, right? Or we can write alpha equal to root under kp if you bring this square on this side, or root under 2.9 into 10 to the power minus 2, because this thing is already given, or it will be equal to 0.17. So we can write the degree of dissociation as 17% if you multiply this thing by 100. So this is your answer. Next question, the equilibrium constant Kp for the reaction, that is PCl5 is decomposing to give us PCl3 plus Cl2, and it is 1.6 at 200 degrees Celsius. The presence at which PCl5 will be 50% dissociated at 200 degrees Celsius is, options are 3.2 atm, B 4.8 atm, C 2.4 atm, and D 6.4 atm. So your time to solve this question starts now. Your time is up. For those who solved it, the correct answer is 4.8. Now, this was our equation according to the question. So initially we are saying that we have only 1 mole of PCl5 and 0 moles of this and 0 moles of this. After the equilibrium is attached, it is said that 50% is being dissociated. So we are moving from 1 to 0.5. Here we are getting 0.5 because 1 mole of this is giving 1 mole of this, and similarly we are getting 1 mole of Cl2 to give from 1 mole of PCl5. So we can write from 0.5, it will be also 0.5. Now what will be the total number of moles? We will add these three, which will give us 1.5. And hence we can calculate the partial pressure as what? Mole fraction multiplied by the total pressure for PCl5. Similarly, for mole fraction of PCl3, it is 0.5 by 1.5. Okay, from here. And for mole fraction of chlorine, it is 0.5 by 1.5. And each of these is multiplied by the total pressure. Now, if you put all of these things into Kp, that is your dissociation constant, we get it as 1 by 3p. Now Kp is already given 1.6. If we equate this, we'll get the pressure as 4.8 atm as the correct answer. Okay, so this was for the question session today. Thank you.